I'm going to start out by noticing that we have a lot of cars here listed, tables, different cars, the weight of those cars, and then their fuel efficiency. So you can see some different cars, probably made by different brands, and then how fuel efficient those cars are. So that's all that this table is doing. So what we've done is we've actually taken this table and then we've created a scatter plot. So you've reviewed scatter plots in previous grade levels, but just as a reminder, the way that scatter plots work is you take one of your variables, so weight, and you put it on the x-axis, and the other variable put it on the y-axis. And so we have our weight compared to our fuel efficiency. So we want to know and kind of see what relationship there is between the weight of the car and the fuel efficiency of the car. So you can see that each of these little dots here would represent these values. And we're going to talk through some of how to read this graph, just as reminders from what you previously learned in other grade levels. So which point on the scatter plot represent car L's measurements? So if we go to car L, you'll see that right here. So since we looked at our graph and we said that this was our X values on our graph and these were our Y values on our graph, that's what I want to look for comparison. So I see that I want an X value of 1,663 and a Y value of 19. So if you look at your x-axis, we see that it starts counting at 1,000 and then it's increasing by 250 each time. So we're going to have to estimate. So 1,663, well, that number is going to fall somewhere in here. So between 1,500 and 1,750. So we know it's going to be one of these dots in here. And then we also want to see, well, it would be in the y direction, be of 19. And you can see these are counting by twos, so since 20 and 18 are here, it's going to be right in between the 20 and 18. So it looks like it's going to be this point here. It's going to be representing part L. So those measurements for that point are going to be this, written as an ordered pair. So your X value is 1,663 and your Y value is 19. So that's how you'd write the ordered pair to represent that point. What is the fuel efficiency of the car with the greatest weight? So we want to look through and figure out where our greatest weight is. So we could look through our table and find the largest number, or we could look at our graph and say, okay, well, the largest weight is going to be somewhere over here. So we see this number, and it's approximately halfway between 2,250 and 2,500, and it happens when the fuel efficiency is 16. So it might be faster if I go try to find the 16 fuel efficiency and see if I have one that is 2,000 something. So this one is, but we want the larger one. Okay, so it must be car G is the one that we're referring to, and that is at 16 miles per gallon for car G. The car with the greatest fuel efficiency. So if we look at fuel efficiency, we want our largest fuel efficiency, which you see would be this number here at 30, and we want to know what that weight is. So it's hard to guess on this graph. I mean, we could estimate, but we have our actual values over here. So if I could find the fuel efficiency at 30, then I'll be able to find my values. So if I see 30, all the way down here at the bottom, so it is car Q, and that weight is 1,234 kilograms. Car S weighs 1,912 kilograms and gets 16 miles per gallon. On the scatter plot a point that represents car S's measurements. So if I added S to this table, so the weight was 1,912, and then the fuel efficiency was 16. If I go back up here to my picture, I would graph the ordered pair, 1,912,16. So I could go up here and I'd say, okay, well, it's going to be pretty close to 2,000 and it's going to be at 16. I see a point that's actually already there, but if I look actually over here, this is point F. And I see that that number is a little bit bigger than this number. So I'm going to plot it just a little bit over here and I'll label it as S. Cars N and O shown in the scatter plot are made by the same company. Compare their weights and fuel efficiencies. Does anything surprise you about these cars? So to get my specifics, I'm going to go over to my chart. and I see N and O are the ones I'm comparing. So we want to compare their weights and their fuel efficiencies. All right, so if I look at these, I want to kind of see where they're falling in the scatter plot. So I'm going to go find N, and N is going to be at the point 1,432, 25. So that's going to be somewhere in here and then up to 25. So it's probably this point. I'll label that one as N. The next one is going to be 1,987, 18 for my point O. So I'll go over here, almost at 2,000, all the way up to 18. So this one is point O. So looking at these, I see that car N has a lower weight and a higher fuel efficiency, whereas car O has a higher weight and a lower, or a lower fuel efficiency and a higher weight. So there's actually nothing unusual about these points, and they fit the trend of the data pretty well. So a different car company makes car F and G compare their weights and fuel efficiencies. Does anything surprise you about these cars? So if we look at F and G, that's these two. So immediately I notice their fuel efficiencies are the same. So let's see where they actually are on our graph. So I see that F is at 1,962, 16. So that's going to be this point right here next to the F that I already have. And then G is 2,384, 16, which is going to be this point. So what I noticed here is that their weights are different, but their fuel efficiencies are similar. So this is surprising because heavier cars are supposed to have less fuel efficiency. So you would think as it gets heavier, the fuel efficiency would actually be even less than this. So this doesn't typically follow the trend that we're seeing. As the weight of the cars increase, what happens to the fuel efficiency? So we've talked about it a little bit, but as the weight is increasing, so as that weight is going up, the fuel efficiency is actually dropping. It's actually decreasing. So we could say as weight is increasing, fuel efficiency is decreasing.